All right, welcome back. In this video, what I'm going to do is I'm going to show you how to essentially go the other direction. So in the last video, I showed you how to predict the number of cases on a given day. In this problem, we're given the number of cases and we want to figure out what day this particular number of cases is going to happen on. Right, so this might be a typical exercise, like if you wanted to predict when we're going to hit 100 million cases or 200 million cases, you could use your equation to help you with that prediction. Now, MyOpenMath is going to generate a random number for you. So in this case, MyOpenMath generated 322,518,832, and we want to figure out what day approximately this number of cases is going to occur. All right. So again, just to recap, we might want to remind ourselves what each part of the equation represents. So if you recall from the last video, we said f of t represents the number of new daily cases, and t represents the number of days. Okay. So this number that they gave us here is a number of new daily cases. So they actually gave us f of t, right, which we have said before is the same thing as the y value. So they're giving us the output and we're trying to figure out the input, right? So it's like going backwards from the previous problem that I demonstrated. So I'm going to take that 322,518,832 and I'm going to plug it into this part of our equation. So this is what we'll get. There we go. So now it's plugged in and our job is to solve for t. And this equation, we've done some of these before, just never with context, right? We have solved for an exponent using logarithms before, so that's exactly what I'm going to do. So you'll notice this part of the equation, let me highlight it because I say this and I know you can't see it. Let me get my highlighter out here. This part of the equation is the exponential part, and we want to isolate that so that it's by itself. Okay, so that means I want to get rid of this 4,516.4456. And since it's being multiplied by the exponential part, I'm going to divide this side of the equation by 4516.4456. And whatever I do on one side, I need to do on the other side. So I'm going to divide by 4,516.4456 on the left-hand side as well. We know that on the right-hand side, those are going to cancel out, so all that's going to be left is 1.2060 raised to the t power. I'll go to my calculator to do this part. Okay, so we got 71,409.8786. And there we go. So there's our new equation. All we did, we just moved one piece over to the other side, and now I have that exponential part isolated. So what I'm going to do now is I'm going to use the log property here. I'm going to take the log of both sides of this equation. So I'm going to take the log of 71,409.8786 equals, and again, whatever I do on one side, I have to do on the other. So I'm going to say the log of 1.2060 raised to the t. Okay, so I just took the log of both sides. This should start looking familiar to you guys. We've done this before. All right, now I'm going to use the power property. You guys remember that power property? It tells us that if we have a power inside of a logarithm, we can take that power and move it out front. So I can take this t and I can put it right here in front of the logarithm, getting it out of the logarithm and getting it out of the exponent. Okay, so I'm going to say the log of 71,409.8786 equals t times the log of 1.2060. All right. Now remember, our goal is to get t by itself. That's what we're trying to solve for. That represents the number of days. So I'm going to divide by the log of 1.2060. And whatever I do on one side, I got to do on the other. So they're going to cancel over here. And this becomes our exact answer. You might remember me talking about that in previous videos. Like, this is our exact answer for t. But what we want is a decimal approximation for MyOpenMath. All right, so I'm going to go over here and I'm going to do this calculation on the left-hand side real quick. So I'm going to use my log button. I'm going to say log of 71,409.8786 divided by the log of 1.2060. And I'm going to hit enter. And there we go. So what we find is that t equals 59.6671. Okay, so we would say, if I'm trying to complete the sentence here, it says on day, and then we would put in the day where this number would happen. That would be on day 59.6671. We're actually going to put that number into the blank, but we would just say somewhere around day 59 or day 60, we're going to get 322,518,832 new daily cases of COVID-19. All right, but for MyOpenMath, make sure you input the entire decimal here into the box. I would carry it to 4 decimal places, and it should count it as correct. All right, so that is how we start from raw data to making a scatter plot that represents our data, that represents the growth of the new daily cases of COVID-19, to creating an equation that we can then use to make predictions and answer equations about the pandemic. This is how this math is used.